I hope you are able to see the screen and able to hear my voice. Okay. So in previous class, we have started with ABCD or transmission parameters or chain parameters or T parameters. So these ABCD parameters, they are named as transmission parameters, also chain parameters or T parameters. Now in ABCD parameters, we have seen yesterday that it is also a two-port network having 1 dash port and 2 dash ports. The voltages and currents will assume first that voltage V1 and I1 is the current at input port or port 1 dash, and at port 2 dash the voltage and currents are V2 and I2. Now if we'll be able to express this voltage V1 and current I1 in terms of V2 and minus of I2, then the coefficients of V2 and minus I2 will represent the ABCD parameters, and the equations in linear form are V1 is equal to A V2 plus B of minus I2, or you can say minus B into I2, but the coefficient will be treated as only B because it is a coefficient of minus I2. Okay. And then second equation is I1 is equal to C into V2 plus D into minus of I2. So from these are the linear form of equations. You can write them in a matrix form as well, as this column matrix of V1 I1, then ABCD as a one matrix, and another column matrix as V2 and I2. So this is matrix form notation of ABCD parameters. Then the values of ABCD, you can find it out from these equations. Whenever I2 will become 0, then B and D or these two terms will vanish, and you will be able to find values of A and C. A will be ratio of V1 and V2 at I2 equal to 0, and C will be ratio of I1 and V2 at I2 equal to 0. And if you will substitute V2 equal to 0, that means if output port you will short circuit, then for keeping I2 equal to 0, you have to open circuit the output port, and for keeping V2 equal to 0, you have to short circuit the output port. If you will put V2 equal to 0 in these two equations, these two terms of A and C will vanish, and you will be able to find values of B and D. So that is value of B, it is equal to V1 by I2 at V2 equal to 0, and D equal to I1 by I2 at V2 equal to 0. Okay, so this we have seen yesterday, and the values of A, B, C, D, these parameters are referred as, A is referred as the reverse voltage ratio, C is referred as the transfer admittance, B is referred as the transfer impedance, and D is referred as the reverse current ratio. Okay. And with this, when you want to find these values of A and C, you have to keep output port as open circuit. That means I2 will be 0. And if you want to find values of B and D, then you will keep output port as short circuited, so that V2 will become equal to 0. Okay, so with these values, we'll be able to solve the numericals. So usually numericals will be asked in the exam. So find ABCD parameters of this network. A T network is given to you, having the resistances as 2 ohm, 4 ohm and 10 ohm. So this is the network which is given to you. Now, the standard equations of ABCD parameters, you can write it as V1 is equal to A V2 minus B I2. And second equation is I1 is equal to C V2 minus D I2. So these are the two standard equations, and these are of this form. V1 as a function of V2 and minus I2, and I1 as a function of V2 and minus I2. So we should be able to express these two equations in this form, V1 and I1 as a function of V2 and minus I2. And then the coefficients of V2 and minus I2 will represent the ABCD parameters. So you can use any network simplification method. So I have used for this problem, I have used the mesh analysis method. So which we have already seen in first unit. M number of problems we have solved. So it's very easy network. Now two meshes are there. So we have assumed initially the currents and voltages at ports 1 and 2 are V1, V2 and I1, I2. Okay. Then applying KVL to mesh 1 and 2 will give you, if you will apply KVL to mesh 1, it will give you V1 is equal to twice of I1 plus 10 into I1 plus I2. That is V1 is equal to 12 I1 plus 10 I2. So let us say this is equation number 3 and apply KVL for mesh 2. It will result you the equation as V2 equal to 4 I2 plus 10 I2 plus I1. That is V2 is equal to 10 I1 plus 14 I2. Let us say it is equation number 4. Now you observe equation 3 and 4. What we want, the standard forms are, we should be able to express V1 and I1 in terms of V2 and minus I2. So if you will observe this I1 as a function of V2 and minus I2, if you will observe this equation number 4, that is, it is having the terms V2, I1 and I2. We want V2, I1 and I2. So that is this equation you can form by this fourth equation. Only you have to rearrange the terms. That means I1 as a function of I1 and I2 and V2 you have to write. So take one I1 at one side and other terms on the other side. So that is this 14 I2 you take on this side. So V2 minus 14 I2 will be on another side and divide by 10 so that it will be I1 only. So rearranging equation 4, I1 will be equal to 1 upon 10 into V2 minus 14 by 10 into I2. So that is I1 is equal to 0.1 V2 minus 1.4 I2. So let us say this is equation number 5. So we got the second equation which is of the standard form of ABCD parameters. So we will be able to find values of C and D from this equation. Okay. That is equation number 5. Now we want V1 to be expressed in terms of V2 and I2. So now in this third equation, it is the equation of V1, I1 and I2. We want V1, I2 and V2. So instead of this I1, it should be V2, I2 and V1. Okay, so this equation you have found out from this fourth equation. After rearranging this, we have got I1 is equal to 0.1 V2 minus 1.4 I2. So substitute this value of I1 from equation 5 in equation number 3. So that you will get V1 is equal to 12 into this I1 value, which is from this equation number 5 I have substituted, plus 10 times I2. Okay. Then simplify this equation, club all the terms of V2 together, I2 together and V1 together and keep V1 on one side and V2 and minus I2 or I2 on another side. Okay. So after rearranging this, we'll get V1 is equal to 1.2 V2 minus 6.8 I2. Let us say this is equation number 6. Now you compare equation 5 and 6 with these standard equations of 1 and 2. So if you will compare this equation 1, that is V1 is equal to A V2 minus B I2 with equation number 6. So that is V1 is equal to 1.2 V2 minus 6.8 I2. So from this, you can easily say that A value is 1.2 and this B value, it is 6.8. So I have got this value of A as 1.2, B as 6.8. Now, if you will compare equation number 2 and 5, so which is I1 is equal to CV2 minus DI2, and equation number 5 is I1 is equal to 0.1 V2 minus 1.4 I2. So from this you can say that C value is 0.1 and D value is 1.4. So I have written C as 0.1 and D as 1.4. And if you will find the values of A and D, they are simply the ratios of voltages and currents, so they don't have any unit, whereas B is the ratio of V divided by I, so that is, it represents impedance, so that's why its unit will be ohm, whereas C is the ratio of I upon V, that is the admittance, and its unit is ohm. So that's why unit of C is mho, whereas unit of B is ohms. And A and D will have no units. Okay. So I hope you have understood how to tackle the problem. Then I have simulated the same circuit in Tinkercad. This is the link which I have provided it to you. So you can put this link in your browser window so that this circuit will appear. Now in this circuit, what we have to do? Once we have to apply input at port 1, and once you have to keep port 2 as open circuit, so that this I2 will become 0, and once you have to short circuit this output port so that voltage V2 will become equal to 0. And then note down the values of I1 V1 and I2 V2. So these voltmeter and ammeter readings you have to note down and take ratios of these to get the values of A, B, C, D parameters, and the values which I have got from this simulation results, they are matching with that of the analytical one. Okay. Then the next numerical, find ABCD parameters of this pi network. Pi network is given to you. If pi network is given to you, you can apply node analysis. If you will apply node analysis method, then your answer you can get it quickly. If you want to find, if you want to apply KVL, or if you want to use mesh analysis method, then you have to convert this pi network into T network. So how to convert this pi network into T network? This is a simple delta. So convert this delta into star. So if you will convert this delta into star, you will be able to convert this pi network into T network. So I have converted this delta into star. So if you want to convert this delta into star, the values of R1 will be 20 into 5 divided by sum of all the resistances, 20 plus 5 plus 15. For R2, R2 is equal to 5 into 15 and divided by all the sum of all the resistances, and R3 is equal to 20 into 15 divided by sum of all the resistances. So once you will be able to find the values of R1, R2 and R3, simply the network will be replaced by this. Instead of pi, it will become a T network, and the resistances will be this R1 as 2.5, R2 as 1.875, and this R3 as 7.5. Okay. So now you can apply KVL for this particular mesh 1 and mesh 2. So applying KVL to mesh 1 and 2, two equations will be there. So these two equations are V1 is equal to 10I1 plus 7.5 I2. This is one equation. And another equation is V2 equal to 7.5 I1 plus 9.375 I2. This is the second equation. Now what is the standard form of equation of ABCD parameters? These are the two. That is I1 is equal to function of V2 and minus I2. That means we want equation in terms of I1, V2 and I2. So if you will observe this second equation, it is in the form of V2, I1 and I2. Okay, so you can rearrange this equation equation 2, so that this I1 term will be on one side and I2 and V2 terms on another side, so that you will get this equation number 2 in the form of this equation. And Then if you will substitute that value of I1 here, you will find that this equation 1 will become now the equation in terms of V1, I2 and V2. Okay, so now you can rearrange this equation in this form. V1 is equal to function of V2 and minus I2. And then the coefficients of V2 and minus I2 will represent your ABCD parameters. Okay, so standard format of equations of ABCD parameter I have mentioned here. And then rearranging this equation number 2, that is I1 is equal to 0.13 into V2 minus 0.11 I2. So this is equation number 5. Substitute this equation number 5 or the value of I1 in equation 1. So that you will get V1 is equal to 10 times this value of I1 as substituted from equation 5 plus 7.5 I2. Then simplify this equation so that you club all the terms of V1 together, V2 together and I2 together. And then rearrange this equation so in such a way that it will be V1 as a function of V2 and minus of I2. So here we got V1 is equal to 1.3 V2 plus 6.4 I2. Let us say this is equation number 6. Now you compare this equation 6 and 5 with these equations 3 and 4. So if you will compare this equation 6 with equation 3, you will find that coefficient of V2, it is nothing but A. So A will be 1.3 and coefficient of minus I2 is B. So B value, it is minus 6.4. So I got value of B as minus 6.4. And if you will compare this equation number 5 with equation number 4, you will get the coefficient of V2, it is C, and coefficient of minus I2 is D. So from this you can say C is equal to 0.13 and D is equal to 0.11. So I got this values of C as 0.13 mho and D as 0.11. As we know, units of B and C, they are ohm and mho, and units of A and D, they are having no units. Okay, so this is the answer. Then I have simulated this circuit in Tinkercad. So these links I have given it to you. You can put this in your browser window and you will get this circuit. So it is simple. We have applied the input voltage at port 1 and port 2, once we have open circuited it and once we have short circuited, so that once I2 will become 0 and another time V2 will become 0. And then take the ratios of this, note the readings of V1, I1, V2, I2, and then take the ratios so that you will be able to find values of A, B, C, D. And the values of simulated results, they are matching with that of the analytical one. Okay, then next problem is find ABCD parameters of this network. Again, here you can find it is a pi network or a delta is there inner. This inner loop is nothing but a delta. You can convert this delta into star and then you can apply the KVL or you can use the mesh analysis. So I have converted this delta, inner delta into star. So all the values of resistances are equal, 2, 2, 2. So the values of all the star values of resistances R1, R2, R3 will be same. And how to find that? So it will be 2 into 2 divided by 2 plus 2 plus 2. So it is 0.66 ohm. So all the values of R1, R2 and R3 will be 0.666. Okay. Then 1 ohm resistance is in series with this and 1 ohm resistance is in series with this. So that these two elements will become 1.66, 1.66 and this third element will be will remain as it is 0.66. So this is now the T network. Now for this T network, we have solved this problem initially also. So we'll I think you will be able to find ABCD parameters of this. So simply you apply KVL for this particular both these meshes, initially you assume that voltages and currents as V1 and I1, V2 and I2, and then apply KVL to both these meshes. So if you will apply KVL to these two meshes, you will result it will result you the two equations. Now these two equations you have to rearrange in such a way that it will be the equation in the form of this V1 and I1 as a function of V2 and minus I2. Okay. So if you will rearrange these equations in this form and compare it with the standard format equations of ABCD parameter, the coefficients will be the values of A, B, C and D. So these are the values, and then simulated this circuit, same circuit in Tinkercad. This is the link, and noted down the voltage and current readings by open circuiting port 2 once and short circuiting port 2 another time, and applying the voltage at port 1 and finding after noting the voltages and current readings, taking the ratio, I have found out the values of ABCD, and they are matching with the analytical one. Okay. Then last problem we'll solve for this, that is find ABCD parameters of this network. Now again you can find that this pi network is there of 1 ohm, 2 ohm and 2 ohm. That is, they are forming the delta. You can convert this delta into star, and then you can add it with other resistances so that it will become a T network, and then you can solve the problem. Or if you will not convert delta into star, even in previous numerical, you can tackle it by this way. Simply, this is a network having now 3 meshes. So 3 meshes are there. So 3 equations will be resulting after applying KVL to all 3 meshes. Okay. So I assumed I1, I2 and I3 are the currents in these 3 meshes, and the voltages applied, they are V1 and V2 at port 1 and 2. Okay. Now after this, I'll apply KVL for mesh 1, 2 and 3. If you will apply KVL to mesh 1, 2 and 3, the equations will be V1 is equal to 3 times I1 minus 2 times I3. Let us say this is equation number 1. Then V2 is equal to 2 times I2 plus 2 times I3. Let us say this is equation number 2. And after applying the KVL for this middle loop or middle mesh, I'll get 0 is equal to minus 2 I1 plus 2 I2 plus 5 I3. Say this is equation number 3. Now, in the standard form of ABCD parameters, there are only 4 variables. They are V1, I1, V2 and I2. Okay. So we won't want I3 as the variable. So from equation 3, you find out the value of I3 in terms of I1 and I2 and substitute this value of I3 in equation 1 and 2. So that it will be equations in V1, I1 and I2 or V2. Okay. So first remove this I3 variable, and in order to avoid this, we have converted that delta into star so that there won't be any I3 variable. But even if you will solve by this method, no problem, no issue. So from this you can find rearrange equation number 3 so that I3 value will be this 2 divided by 5 I1 minus 2 by 5 I2. So this is value of I3. Now substitute this value of I3 in equation number 1 and 2. So if you will put this in equation 1, you will get V1 is equal to 3 I1 minus 2 times I3. I have substituted the value and then simplified this and then clubbed all the terms, similar terms together, and the equation, resultant equation is V1 is equal to 3.8 I1 plus 0.8 I2. Say this is equation number 5, and after putting the value of I3 in equation number 2, it will give you V2 is equal to 2 I2 plus 2 into I2 value of this I3. Then it has given me the equation as V2 is equal to 0.8 I1 plus 1.2 I2. Say this is equation number 6. Now, if you will compare this 5 and 6 with the standard form of these ABCD parameter equations, this second equation is I1, V2 and I2. And this sixth equation is also having the terms V2, I1 and I2. But only difference is we want I1 on one side and V2 and I2 on another side. So rearrange this equation number 6 so that you will get the value of I1 as you keep this 0.8 I1 term on one side and V2 and I2 terms on another side. So that you will get I1 is equal to 1 upon 0.8 V2 minus 1.2 by 0.8 into I2. So that means I1 is equal to 1.25 V2 minus 1.5 I2. So this is equation number 7. Now if you will compare this equation with the standard form of the ABCD parameter, you will be able to find that this is the value of C, 1.25, and this is the value of D, that is 1.5. Okay. And similarly, you put this equation number 7 in equation number 5 so that it will result you this V1 is equal to 3.8 into the value of I1 plus 0.8 I2. After simplifying this, you will get V1 is equal to 4.75 V2 minus 4.9 I2. If you will compare this equation with the standard form of ABCD parameter, then you will find that this coefficient of V2, it is nothing but A. So A is 4.75 and coefficient of minus I2, that is nothing but B, which is 4.9. So these ABCD parameters have got these values. Then again you can give the units. For A and D, there won't be any unit. For B, it will be ohm, and for C, it will be ohm. Okay. Then I have simulated again this circuit. So this is the link. You can put it in your browser window. I have applied input at port 1 in both the cases, and in first case, I have open circuit at port 2 so that I2 will become 0. And in second case, I have short circuited this port 2 so that this voltage will become 0, V2. Okay. And then noted the values of V1, V2, I1, I2 and taken the ratios to find the values of ABCD parameter, and they are matching with the analytical one. Okay. So I hope you have understood all the parameters. We have seen 4 parameters: Z parameter, Y parameter, H parameter and ABCD parameter. So if any network is given to you, you should be able to find all these parameters. Okay. And I hope we have covered sufficient numericals there with you, and you can tackle the problems. Now in these problems, it is usually asked to find the symmetry and reciprocity. So how to find symmetry of a network? That I have already told you. If a network is called to be symmetrical when its voltage and current ratio is same at both the ports. That is, the input impedance is equal to output impedance. That is the ratio of V1 I1 and V2 I2. They are same. That is both driving point, that is they are equal to the driving point functions. So what is the condition for symmetry? This is the condition for symmetry. If Z11 value is same as Z22, then you can say that that network is a symmetrical one. If Y11 is same as Y22, then also you can say that network is symmetrical. If A value is same as D value, then it is a symmetrical network. And if H11 into H22 minus H12 into H21, if this results 1, then the network is symmetric. So these are the symmetry conditions in all parameters. If you want to say symmetry from Z parameters, this should be equal. If you want to state the condition of symmetry in terms of Y parameter, then this is the condition. Then in terms of ABCD parameter, this is the condition, and in terms of H parameters. Okay. And then reciprocity. So the ratio of voltage on one port to the current at other port, if it is same as that of the voltage and current with interchanged positions, that is, they should have equal transfer functions. That is the passive time invariant network. The network is called as the passive time invariant network. That means V1 by I2 is equal to V2 by I1. So that means the condition of reciprocity, if in terms of Z parameters, you can say that if Z12 is equal to Z21, then the network is reciprocal, or it is a reciprocal network, you can say. If Y12 is equal to Y21, it is a reciprocal network. If AD minus BC results you 1, then it is a reciprocal network. If H12 is equal to minus H21, then it is a reciprocal network, or otherwise it is not reciprocal. And here symmetric also, if this is symmetric if these conditions matches, otherwise it is not symmetric. Okay, so you may be asked to solve the numerical, and based on the values of these parameters, you have to find the values of the parameters, either Z, ABCD, Y, H parameters, and from these values you have to conclude about the network, whether it is a symmetric network or it is a reciprocal network. So you can, I hope you will be able to comment on the network. Okay, and last point of this parameters is the applications of these parameters. So what is the application of all these parameters? So first major application is circuit analysis of any two-port network. So any two-port network you can analyze using all these parameters. Okay, so that is first application of these parameters. Second application is your H parameters. You might have seen your in your EDC or electronic circuits transistor. So small signal BJT amplifier. So that you have characterized that transistor using the H parameters. So that is HIE, HFE, HRE, and HOE. So these are the input impedance, forward current gain, reverse voltage gain, and output admittance. So these HIE, HFE, HRE, and HOE, these are nothing but they are the H11, H21, H12, and H22. That is ratio of V1 and I1, I2 and I1, V1 and V2, and I2 and V2, when either V2 is 0 for first two conditions and I1 is 0 for second conditions. That is, in first condition, you have to short circuit the output port, and in second case, you have to open circuit the output port. So these H parameters, you have already done the small signal BJT amplifier characterizing transistor using H parameters. So for that particular application, these H parameters are very helpful. Then third major application is cascade combinations of these two networks. That is, if only standard networks are given to you, that is T network, pi network, lattice network, bridge network, then you will be able to find these parameters. But if such number of networks are connected in cascade, they may be connected in series, they may be connected in parallel to form different circuits. So now it may be amplifier, it may be oscillator, or it may be filter, or whatever it may be. While designing, you have to design all these circuits and you have to cascade them. Cascade means you have to connect in either in series or in parallel, so that these circuits will work properly. So now if you want to analyze these particular circuits, then you can use these parameters, performance parameters, to design these particular networks. If you want to design transmission lines, or if you want to analyze the transmission lines, then T parameters or ABCD parameters, they are very helpful. So that is the application of ABCD parameter. And you can find the transfer function for a given network with termination in terms of two-port parameters. So you should be, you are able to find the transfer function or network functions, and how to find that. So that is the next part, which will be of this particular unit that will start from tomorrow. I hope today time will not allow us. So network functions and the transfer functions, that will be finding. So for this purpose, you will require Laplace transform, and the next point is your Laplace transform, and after Laplace transform, we'll go for finding this transfer function and all. So first I'll stop recording and then